Okay, let's start another problem in theory of computation. Uh, Consider the set sigma star of strings over the alphabet. Sigma is equal to 0, 1. So that is sigma star. So basically this is clean star, that you have all the possible concatenations on this. Sigma star with the, okay, so this is the same sentence with the concatenation operator for the strings. Okay, so the operator out here is the concatenation operator, which you can give by symbol like this or dot or anything. Okay, so you are concatenating strings, uh, and then you have to tell that whether this algebraic system that you will get does not form a group, forms a non-commutative group, does not have a right identity element, forms a group if the empty string is removed from sigma star. Okay, so what algebraic system do we have? The set. Okay, whenever you have an algebraic system, you have two things. Okay, you have a set and you have an operator on that set, and when you have these two things, this is an algebraic system. Okay, and there are different types of algebraic systems like rings, monoids, and semi-groups and groups and so on. So in this case, we have to consider this case. It's particularly interested in groups. So what is the set? The set is sigma star out here on this alphabet. So that means that the elements that we have in our set is empty string. Okay, if you concatenate them once, you have 0, you have 1, you have 0 0, you have 0 1, and 1 1 1 0, and so on. Okay, that's the set you have out here. Okay, and your operator. Okay, so this is the set that you have, and the operator that you have is concatenation, given by this symbol. Okay, so that is concatenation, and for this algebraic system you have to tell whether this is a group or not. And how do you know whether something is a group or not? So what are the characteristics of a group? An algebraic system is a group if it satisfies 4 properties. Okay, the first property is of closure. Okay, closure means whenever you apply this operator to these elements of this set, it should always belong to the same set. Okay, so if I concatenate 0 with 1, I get 0 1, so I'm in the same set. So that's closure. And the second thing that should be satisfied is first I think talk about associativity. Okay, that's called associativity. So what is associativity? In associativity you have is, so suppose you have some operation like this, A, B, C. Okay, and in the case of associativity, this should be equal to this thing. Okay, it doesn't matter which you operate first. That's the idea of associativity. Whether you operate B and C first and then operate the result on A, or you first operate A with B and then operate the result on C, it doesn't matter. It's if it doesn't matter, that's associativity. So that's the second property that should be satisfied for an algebraic system to be a group. And then there is a third property called identity. Okay, so identity is that you should have some element in your set. So let's say element E, and if you operate it with some other element, let's say A, this should be equal to A operated on E and should be equal to A. So basically what this is saying is that you should have an element that is called an identity element, and when you operate it with some other element, you get that other element back. Okay, so when you operate A with E out here like this or this, you always get back A. So that's the idea behind identity element. Okay, and the fourth property is inverse, existence of inverse for every element. So for every element there should be an inverse. That means that you should be able to find some element for A. Let's say you have an element A, and if you operate this with some other element which is the inverse of A, you should get the identity element. That's the idea of inverse. Okay, operate A with some other element, and if you get the identity element, then this is the inverse, and vice versa. Okay, so that's the idea of identity element. So now we can talk about this particular case. That was the quick review of what groups are, and let's talk about this case. So do we satisfy closure? Okay, so if you do any concatenation with all these set, you will always end up in sigma star, because sigma star will basically include all the possible strings that you can have. So closure is satisfied out here. What about associativity? Okay, so if you talk about associativity, you'll find that this is also satisfied no matter how you concatenate, whether you concatenate B with C first and then with A, or A with B and then with C, you will have associativity. So associativity is satisfied too. What about identity? Can we find an identity element? Yes, this empty string is an identity element, because no matter what you string you take, so suppose you take 0 and concatenate with epsilon, you will end up with 0. Alright, you concatenate epsilon with 1, you will end up with 1. So this epsilon, this empty string, is definitely the identity element, so this is satisfied as well. And then we come to this fourth thing. What about inverse? Okay, can we find an element if we concatenate with some other element and we get this identity element, and this should be true for all the elements in the set. So can you do this for 1? Can you find some element if you concatenate 1 with that element? Okay, you have to concatenate 1 with something and you should end up with this identity element, which is empty string. Can you find this thing? Okay, it turns out no, because no matter what you do in this case, okay, if you concatenate with this with something, you will always get a bigger string, or if you concatenate it with epsilon, you will at least have 1 but not less than 1. So there is no way you can get empty string by concatenating 1 with something. Okay, the only case you get this is when you concatenate empty string with empty string, you get an empty string, but this should be true for every element. For every element you should be able to find an inverse. In this case, the only inverse we find is for epsilon, which is itself. That means we cannot find inverse for every element, so this inverse property is not satisfied, and that means that this is not a group. We have to satisfy all the 4 properties to make it a group, and that's why this option A is correct. It does not form a group. Okay, and you can see that there's no point of talking about non-commutative group or right identity element, because it does have a right identity element. Forms a group if the empty string is removed from. This is obviously wrong. So yeah, this A is the correct choice.